heartbreaking incident in Florida involving the electrocution deaths of two teenagers highlights the ever-present dangers of electricity, especially near water. While initial reports suggest no immediately visible damage to the boat lift involved, a thorough investigation is needed to determine the root cause and whether negligence played a role. Several factors could have contributed to this tragedy. Firstly, faulty wiring within the boat lift itself could have allowed electrical current to leak into the surrounding water. This could be due to damaged insulation, loose connections, or corrosion of electrical components. Secondly, improper grounding of the electrical system could have created a path for electricity to flow through the water to ground. A properly grounded system provides a safe route for fault currents, preventing them from energizing conductive materials. Thirdly, the absence of a ground fault circuit interrupter, also known as a GFCI, could have been a critical factor. GFCIs are designed to detect even small imbalances in electrical current, indicating a leakage to ground. When a ground fault is detected, the GFCI trips, quickly cutting off power and preventing electrocution. The National Electrical Code, known as the NEC, mandates GFCI protection for outlets located near water, including those serving boat lifts. NEC Section 555.3, for example, requires ground fault circuit interrupter protection for all receptacles installed on docks, boathouses, and similar locations. The absence of a properly functioning GFCI could have significantly increased the risk of electrocution. Fourthly, stray voltage from nearby sources could have also contributed to the tragedy. Stray voltage, also known as neutral-to-earth voltage, is the presence of small electrical currents in the ground. While stray voltage is usually not dangerous, it can become hazardous under certain conditions, particularly when combined with other factors. To understand the potential causes, it's helpful to delve into the basics of electrical systems. Electricity always seeks the path of least resistance back to its source. In a properly functioning electrical system, the current flows through the intended conductors, such as wires, back to the power source. However, when there's a fault or a break in the insulation, the current can find an alternate path to ground, which could be through a person in contact with water and an energized object. The severity of an electric shock depends on several factors, including the amount of current flowing through the body, the path of the current, and the duration of the exposure. Even a small amount of current can be lethal, especially when it passes through the heart. The resistance of the human body varies depending on factors such as skin dryness and the presence of moisture. Wet skin significantly reduces resistance, making a person more susceptible to electric shock. Water is an excellent conductor of electricity, so being in contact with water increases the risk of electrocution. In the case of the two teenagers, the water in the canal likely provided a conductive pathway for electricity to flow from the boat lift to their bodies. The fact that they were touching the boat lift, which may have been energized due to a fault, further increased their risk. It's important to note that electrical accidents are often the result of a combination of factors, rather than a single cause. In this case, it's possible that faulty wiring, improper grounding, the absence of a GFCI, and the presence of water all contributed to the tragedy. A thorough investigation should include a detailed inspection of the boat lift's electrical system, including the wiring, connections, and grounding. The electrical system should be tested for any signs of damage or deterioration. The presence and functionality of GFCI protection should also be verified. The investigation should also consider the possibility of stray voltage from nearby sources. If stray voltage is detected, the source should be identified and corrected. Furthermore, it is important to examine the electrical installation against applicable codes and standards. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation and maintenance of electrical systems. Compliance with the NEC is essential to prevent electrical accidents. In addition to the technical aspects, it's also important to consider the human factors that may have contributed to the tragedy. Were the teenagers aware of the potential dangers of electricity near water? Was there adequate signage warning of the hazards? Was the boat lift properly maintained and inspected? Addressing these questions can help prevent similar accidents from happening in the future. Electrical safety is everyone's responsibility. Homeowners should regularly inspect their electrical systems for any signs of damage or deterioration. They should also ensure that all electrical outlets near water are protected by GFCIs. If you notice any electrical hazards, such as frayed wires or sparking outlets, you should immediately contact a qualified electrician. Never attempt to repair electrical equipment yourself unless you are a qualified electrician. Electricity is a powerful force that can be deadly if not handled properly. By taking precautions and following safety guidelines, we can prevent electrical accidents and save lives. Firstly, ensure all electrical work is performed by a qualified electrician. Secondly, regularly inspect electrical cords and appliances for damage. Thirdly, replace damaged cords and appliances immediately. Fourthly, never overload electrical outlets or circuits. Fifthly, keep electrical appliances away from water. Sixthly, install ground fault circuit interrupters, or GFCIs, in areas where water is present. Seventhly, test GFCIs monthly to ensure they are functioning properly. Eighthly, teach children about electrical safety. Ninthly, never touch electrical equipment with wet hands. Tenthly, if you see a downed power line, stay away and call the power company. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical safety. It is updated every 3 years to reflect the latest advances in technology and safety practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety of electrical systems. Article 90 of the NEC covers the purpose and scope of the code. Chapter 1 of the NEC covers general requirements. Chapter 2 of the NEC covers wiring and protection. Chapter 3 of the NEC covers wiring methods and materials. Chapter 4 of the NEC covers equipment for general use. Chapter 5 of the NEC covers special occupancies. Chapter 6 of the NEC covers special equipment. Chapter 7 of the NEC covers special conditions. Chapter 8 of the NEC covers communications systems. Chapter 9 of the NEC contains tables and examples. For example, NEC Table 310.15b16 provides ampacity ratings for insulated conductors. NEC Section 210.8 requires ground fault circuit interrupter protection for dwelling units in bathrooms, garages, and outdoor locations. NEC Section 250.50 covers grounding electrode systems. The investigation into the electrocution deaths of the 2 teenagers should carefully consider all of these factors. It should also involve experts in electrical safety and accident reconstruction. The goal of the investigation should be to determine the cause of the accident and to identify any measures that could have prevented it. The findings of the investigation should be used to educate the public about the dangers of electricity near water and to promote electrical safety. Furthermore, stricter enforcement of electrical codes and regulations is needed to prevent similar tragedies from happening in the future. Electrical inspectors should be properly trained and equipped to identify and correct electrical hazards. The public should also be encouraged to report any electrical hazards they observe. The electrocution deaths of the 2 teenagers is a tragic reminder of the importance of electrical safety. By taking precautions and following safety guidelines, we can prevent electrical accidents and save lives. Remember to always be aware of the potential dangers of electricity, especially near water. If you see any electrical hazards, report them immediately. And never attempt to repair electrical equipment yourself unless you are a qualified electrician. The information provided here is for general educational purposes only and should not be considered professional advice. If you have any questions about electrical safety, consult with a qualified electrician or electrical inspector. Furthermore, it is important to remember that electricity can be dangerous. Always exercise caution when working with or around electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Never take chances with electricity. Your life may depend on it. The circumstances surrounding this incident warrant a comprehensive examination of potential negligence. Negligence, in a legal context, refers to a failure to exercise the level of care that a reasonably prudent person would exercise under the same circumstances. To establish negligence, several elements typically need to be proven. Firstly, a duty of care existed. Secondly, there was a breach of that duty. Thirdly, the breach caused an injury. Fourthly, actual damages resulted from the injury. In the context of the boat lift electrocution, a duty of care likely existed on the part of the homeowner and potentially other parties responsible for the maintenance and safety of the electrical system. This duty would require them to take reasonable steps to prevent foreseeable harm to others, including ensuring that the boat lift and its electrical components were properly installed, maintained, and safe for use. The breach of duty element would focus on whether the homeowner or the responsible parties failed to meet this standard of care. This could involve failing to inspect the electrical system regularly, neglecting necessary repairs, or failing to install or maintain proper safety devices such as GFCIs. Causation requires establishing a direct link between the breach of duty and the electrocution deaths. This means showing that the faulty wiring, lack of GFCI protection, or other negligent acts were a substantial factor in causing the teenagers' injuries and subsequent deaths. Finally, damages would encompass the financial and emotional losses suffered by the families of the deceased teenagers, including funeral expenses, lost future earnings, and pain and suffering. Establishing negligence in a case like this can be complex and require the expertise of electrical engineers, accident reconstruction specialists, and legal professionals. Thorough investigation, evidence gathering, and legal analysis are crucial to determine whether negligence played a role in this tragic event. In conclusion, this tragedy highlights the critical importance of electrical safety, especially around water. A thorough investigation is necessary to determine the cause of the accident and whether negligence contributed to the deaths. By learning from this tragedy, we can take steps to prevent similar accidents from happening in the future and ensure the safety of our communities. The loss of these two young lives serves as a stark reminder of the potential dangers of electricity and the need for constant vigilance.